Hello, my name is Gloire Bambiza. I conducted research on the student-to-teacher ratio in the state of Washington. Your questions on the stabilization of the ratio over time and whether the ratio would ever reach 15 to 1 are answered in the analysis below. I manipulated the data given to me using rational functions in Microsoft Excel to examine how different graphs affected the behavior of the ratio, and the results were different but very closely related. The figure shown represents the number of students and teachers in the state of Washington X years after the school year 2000-2001 as it was assigned to me. A quick glance at the data shows that the ratio would be around 1 million to 50,000, which is 20 to 1. This second figure shows the number of students X years after the 2001 school year in a linear graph. The equation of the graph is given here and is used later to find other equations. The graph shown here represents the number of teachers in Washington X years after 2000-2001. As the figure suggests, the number of teachers increased over the years. The linear equation for the graph is also shown. The Washington student population is a manipulated result of the linear graph for students shown earlier. The one shown above is a quadratic graph of number of students after X years. I created the quadratic graph to compare it to the linear one in order to see which one represented data beta. The conclusion is explained in the last graph. Similar to the previous graph, this is a quadratic graph of the number of teachers X years after the 2000-2001 school year. The line grows as closely as it can between the different data points on the graph. Using the data given and the four graphs shown earlier, I divided the number of students by the number of teachers to find the ratio based on the data as it's shown in this graph. As for the other two ratios, I used the equation function in Excel, the number of years after 2001, which represents the A2, and the linear and quadratic equations from the graphs to make a rational function, as it is shown here, that determine the student-teacher ratio based on the linear and the quadratic equations. The graph shown here represents the different ratios and how they all correlate. The blue, red, and green data points represent the ratios based on data, the linear function and the quadratic functions respectively. As it is self-evident, the linear ratio represents the data best because it's consistent and balanced at the x values as the x value increases. When analyzing the different graphs, the data for the state of Washington showed that the number of students and teachers were increasing at a steady pace, but the ratio was at 19 to 1 on average and was decreasing very slowly. The ideal ratio of 15 to 1 can be attained, but the given data was limited at 6 years. However, I manipulated the rational function for the ratio based on the linear graph and approximated the year the ideal ratio could be reached. The closest I found was 184 years after the 2001 school year. Furthermore, I manipulated the data with a graphing calculator and used basic concepts of rational functions. To answer your concern of stabilization of the ratio, I divided the leading coefficients of the students and linear functions to find the vertical asymptotes and limits at infinity. The result was that the ratio can stabilize at 11.6 on the y-axis. If this was to go on infinitely, it would stabilize at 11.6. Or in educational terms, that would be a 12 to 1 ratio for the students and teachers. The project was self-explanatory despite the limit of data. I used the limited resource in order to find multiple solutions to the questions of ideal ratio, and I found the ratio to be 15 to 1 after 184 years. Realistically speaking, 2 centuries is a long time from now, but there are solutions to reach the ideal ratio. The first one would be to train more teachers and build more schools to decrease the proportion of students per school. The second one correlates to the first one because more space is needed for students, and it involves introducing more classes to the current curriculum in order to decrease the number of students in one certain class during a normal class period. The data given to me was really helpful in helping me put this presentation together. I hope it was very informative and you understood the concepts of my research clearly. Thank you for listening to the presentation.